Hello everyone, welcome to my Additional Maths channel. For today's video lesson, I will share with you one of the hot questions from differentiation or derivative. This is a very interesting topic. I do hope that you will enjoy the video lesson. Have fun!
We're looking for two numbers whose sum is 10 and whose product is a maximum. So first, let's try a few sets of numbers to get a feel for the question here. So say we make the first number 1, then the second number will be 9, right? Because 1 plus 9 is equal to 10. Now, what's the product? Well, 1 times 9 will give us a product of 9, right? Cool. So let's try another set of number. So make the first number 2, then the second number will be, well, 10 minus 2 is equal to 8, right? Yeah. Now, what's the product? Well, 2 times 8 will give us a product of 16. Let's try another set of number. Make the first number 3, second number 7, and 3 times 7 will give us a product of 21. So far it looks like we're on the right track because look, the product is getting bigger and bigger, and that's what we're looking for, right? Because we try to maximize the product. Okay, so let's try another set of number. Make the first number 4, second number 6, and 4 times 6 will give us a product of 24. Wow, the product is still getting bigger, so we shouldn't stop. Let's try another set of number. Make the first number 5, second number will be 5, and the product of 5 times 5 is 25. Wow, the product is still getting bigger, so we shouldn't stop. Try another set of number. Make the first number 6, second number 4, and 6 times 4 will give us a product of 24. So for the first time, the product is getting smaller. We don't want that. However, let's try another set of number to see what happens. So first number 7, second number 3, and 7 times 3 will give us a product of 21. So the product is getting smaller again. We don't want that, right? So it looks like, just from the sets of number we've tried so far, it looks like we don't have to go any further. It looks like any more sets of integers we try will just give us a smaller product than the maximum product we've got so far, right? Okay. In addition, would you say that after this set of number, any more sets of integers we try will just be redundant? And what do I mean by that? Look, I want you to compare these two cases. Okay, let's compare this case and this case. Now look, first number being 4, second number being 6, swap. first number being 6, second number being 4, guess what? They give the same product, right? So for two numbers, in this case, any two numbers, if we swap them, well, will still give us the same product, right? Yeah, so it's pretty much pointless for us to try any further sets of integers, right? See, 6, 4, 4, 6, same product, redundant, right? So this case will be redundant, right? So 7 times 3, 3 times 7, see, same product again. So this case is once again redundant, right? Can you see that? Yeah, so in terms of sets of integers we tried, I think we are pretty safe to stop at 5 and 5, right? Yeah, because any more sets we try will just become redundant, will just be the repeat of previous cases, right? However, you might be very tempted to want to make a conclusion that, you know what, I found the answer. To maximize the product, my two numbers must be first number 5, second number 5, and that's going to give us a maximum product of 25. But guys, be careful here. All the sets of numbers we tried so far, they are integers, right? But does the question say that the two numbers must be integers? No. So that means in order to consider all possible cases, we should also consider decimal numbers, right? Yeah, so why don't we try a set of decimal numbers and see what happens, okay? So first number, let's make the first number, say, 5.5. And the second number will be 10 minus 5.5, that's 4.5, right? Now, let's look for the product. So 5.5 times 4.5 will give us a product of 24.75. So we get a product that's slightly smaller than the maximum product we've got so far, okay? But we shouldn't stop though, right? Because we really have to consider all possible cases in order for us to make a very safe conclusion, right? So why don't we make the first number really big? So let's make the first number, say, 9.99, a really big number, and see what happens, okay? So we'll make the first number 9.99. Then the second number will be what? Well, 10 minus 9.99 is equal to 0.01. Now, what's the product for this set of number? So 9.99 times 0.01 will give us a product of, indeed, will give us a product that's very, very small, right? Give us a product of 0.0999, a very, very small product, okay? Yeah, so once again, you might be very tempted to want to make another conclusion. Oh, I don't have to try anymore. This guy, first number being 5, second number being 5, is going to give me the biggest product. Well, once again, we can never make a conclusion until we consider all possible cases, right? Now, if we consider all possible cases of decimal numbers, there's no end, right? We can keep going. We can try forever because there are simply infinite sets of decimal numbers we can try, right? And you never know. Maybe there's one set of decimal number which we try that's going to give us a product that's bigger than 25. We never know until we try them, right? But, well, the fact is, it is simply impossible for us to try every possible set of decimal numbers, right? We can go on forever, right? So that's why now is the time to use all the calculus tools we've learned so far to help us find the exact answer. So let's go the calculus way. So we've got two numbers that have a sum of 10. Now, if we call the first number x, what would be our second number? Well, let's think about this. If two numbers have a total sum of 10. Now, if the first number is x, what's our second number? What would you say the second number will naturally be 10, take out the first number, right? See, 10, total sum, take out the first number, then we get the second number, right? Yeah, so our second number will be total sum 10 minus the first number x, then we get 10 minus x to be our second number, right? 10 minus x. Okay, cool. Now, in this question, we're looking for the product, right? We're looking for the product. In fact, we're looking for the maximum product. So let's write out the product function. So product of two numbers is the first number times the second number, right? That's the product. Now I'm gonna use the symbol P to represent product, okay? So product is equal to, the first number in this case is just x. And the second number in this case is 10 minus x, okay? Now I'm just gonna quickly expand the polynomial by multiplying the x into the second bracket. So x times 10, we get 10x. And x times the second term here, negative x. So x times negative x, we get negative x squared. Okay, so as we can see, we now have a product as a function of what? X. So we now have a product as a function of x. Okay, yeah. Now, what kind of function is this product here? Well, let's look at the highest exponent in this polynomial. So in this polynomial, the highest exponent is 2, and that tells us we have a quadratic function. So the product function in this case is a quadratic function. And what's the graph of a quadratic function? A parabola, right? So in this case, we have a parabola opening up or opening down. Well, look, in front of x squared, we have negative. So we have parabola opening down. Okay, so I'm just trying to understand this question here graphically. So let's draw a graph to represent the product function. So we have a product function denoted as P of x, right? A product as a function of x. So a product as a function of x, where x here is just our first number, right? X here is just our first number. Okay, now, and since the product function here is a quadratic function that has a parabola opening down. So it's a parabola opening down. So we have a graph that looks something like this. Now from the graph, it's obvious that the maximum product occurs where? The maximum product occurs right here, right? See, the highest point on the curve is our maximum product, right? It's our maximum product, right? And now from the previous section, when we talked about critical numbers, we know that the local extreme, whether it's local maximum or local minimum, local extreme always occurs at critical points, right? Yeah, so this is going to be our critical point. So this is going to be our critical point, right? See, maximum always occurs, local maximum always occurs at critical points. In this case, this is the critical point where the derivative of the function, where the derivative of the product function, so the derivative of the product function is equal to 0, right? In other words, if you draw the tangent line to the function at this maximum point, we will get a horizontal tangent line with slope equal 0, right? Yeah. Okay. Now, so we know the maximum product occurs at this critical point where the derivative of the function is equal to 0. So now let's write out the derivative of the function, okay? So if p of x is equal to 10x minus x squared, then the first derivative, then p prime of x is equal to, well, let's take the derivative of this polynomial. by using the power rule, right? So the derivative of 10x is just 10 minus, and the derivative of x squared is 2x, right? Now, in order to find the maximum, we have to set the derivative to be equal to 0. So to find the maximum, to find the maximum, we need to set the derivative of the function to be equal to 0. Okay, so let's set the derivative of function to be 0. So 0 is equal to 10 minus 2x. Okay, so solve the equation here. We get x equals 5, right? So you get x right here equals 5 because 2 times 5 is 10 and 10 minus 10 is equal to 0, right? Good. So we know that this maximum point occurs at x equals 5. So this maximum point occurs at x equals 5. And there we go. Just like that, we found the answer. In fact, we found the first number to be 5, right? And that will give us the maximum product, right? Yeah. So our first number, x must be 5. So x must be 5, x must be 5. And we are ready to write the answer now. Okay, so our answer is, the two numbers are, okay, first number, second number. And our first number is just x. And in this case, x is equal to 5, right? And our second number is 10 minus x. So in this case, that's 10 minus x is 5, right? So 10 minus 5 is equal to 5. Okay, and so 5 and 5 will give us a maximum product. And what is the maximum product? What is the value of the maximum product? So the maximum product is then equal to first number 5 times the second number 5, and that will give us a product of 25. So on the graph, we can show that the maximum product right here has a value of 25. Has a value of 25. Okay? Yeah, so as it turns out, our prediction was in fact correct. Okay, so the two numbers 5 and 5 will give us a maximum product of 25. Maximum product of 25.